Hey guys, we finally have the first minimum viable product for a water cooling vest. So here you'll see the vest, a coupling that took 2 weeks to get from AliExpress. This goes into these fittings here. This is definitely not a permanent solution. This is epoxy that is definitely not stuck to the plastic. And this system isn't sealed. I'll explain it further in a second. Right. So, first you have the power bank. Don't need something as chunky as this. This consumes probably an amp at most. Actually, we can find out the numbers in a second. So, all that this system needs to work is a syringe far smaller than this. Once this is filled up, all that needs to happen is plug it into the power bank. This will slowly fill up, or it'll slowly drain to keep it primed. So this is designed so that the return line is higher than the intake, so that if any air comes through, it goes to the top and the bottom still receives water. This is useful as these quick disconnects are wonderful, but they're not leak-free. So you're always going to lose a couple of milliliters per disconnect, and this system itself isn't sealed yet. I basically drilled the holes and just shoved them in for now. So it's a very temporary solution. Also, you notice the significant kink in that pipe. That might be a limiting factor in the circuit flow. Same for this one here. This is more a proof of concept of something minimally viable. So this copper pipe loops around. It's not the neatest bend. I did have a perfect one that I'll show you in a second. However, I realised that you can't really store anything inside of a tub if it's mostly taken up by loop, and that kind of takes away from the practicality. So as this gradually fills up properly, all you gotta do, stick the cap on it. This also slows down the leaking for now. Once that's done, that's still sticky, we can actually check the current. So it uses, don't know if you guys can see that. So it's 0.2 amps at 5.1 volts, give or take. So it uses very little power. Though you'll also realize the flow is fairly minimal. Though when you're wearing a vest and this is actually packed full of ice, that doesn't really matter. You'll notice that it still feels like it's leaking because it works that well. So here's a demonstration of the quick disconnect as well. Big heads up, make sure that it's not running, otherwise you'll lose far more. All you gotta do, click, it's disconnected. As you can see, a few milliliters lost, not too bad. But when I clip it together, 1 second. So I don't have a mount set up right now. Once that's done, plug it back in. You'll see a little air coming over, but that should get sorted in this. As you can see, just about the air in there. It loops around, and any air gets trapped up here. I will set it up with an ESP32 in future, because if air is trapped in the pump, and to be fair, it's not standing correctly right now. It should be, the output should be vertical. But you'll see the air bubbles trapped, so by cycling it off and on, it slowly pushes it through, which could be beneficial for priming. But yeah, here we have the minimum viable product. I've also changed my mind on a few other categories, so using thermoelectric cooling. Initially I thought would be an absolute waste of time due to the inefficiencies, but I've later decided that while they are inefficient, the size ratio as well as the complexity means that the TEC is far more valuable in this circumstance specifically than any actual air conditioning product. I'll link all of the parts in the description if you guys want to follow along in future, and the next video will be a how-to for this, and every other generation after this shall just be upgrading. So it's just going to be adding a few different parts, definitely swapping out the container. This is not a permanent solution, as you can tell. If I were to start this again, I might use a more powerful pump, but it's fine as it is.